In this video lecture, we are going to see about phytoremediation and soil heating. So let us see about phytoremediation. We all know what is phytoremediation. So it is remediation that utilizes plants to remove, degrade or immobilize the contaminants from the soil, water or air. So it is quite a natural process. And the plants are species used to absorb, accumulate or metabolize or degrade the various pollutants, thereby reducing their concentrations and mitigating environmental risk. And phyto remediation is particularly effective for organic waste materials. And so let us see how the phytoremediation typically works. So we have certain steps in it. First one is a selection of plant. The first step is selection of plant species or cultivars that are well suited for a specific contaminant and site conditions. And certain plant species have a natural tolerance, uptake and accumulation mechanisms for specific contaminants, making their suitable candidates for phytoremediation. So we have to choose the particular plant species for a particular contaminant. And next one is site preparation. The contaminated site is prepared for phytoremediation by removing the debris, tilling the soil and amending it with organic matter or soil amendments to improve the soil structure and fertility. Soil pH, nutrient level, moisture content and other factors are optimized to enhance the plant growth and remediation performance. And next one is the planting and establishment. The selected plant species or cultivars are planted in the contaminated soil or water. The plants may be grown directly in the contaminated site or in specifically constructed treatment sites such as construction wetlands, vegetated filter strips or hydroponic systems. And next one is the contaminant uptake and accumulation. Once established, the plants absorb contaminants from the soil, water, and they translocate them to the above ground tissues such as leaves, stems, roots. And the contaminants may be stored in plant tissues, sequestered in vacuoles, or metabolized into less toxic or volatile forms. So now what are the different methods? It is phyto extraction. In this method, plants accumulate the contaminants in the above ground mass, which can be harvested and removed for disposal. And next one is the rhizodegradation. In rhizodegradation, plants release roots, exudates and enzymes into the rhizophore. The soil zone influenced by root activity to promote a microbial activity and enhance contaminant degradation. And next one is the phytostabilization. In phytostabilization, a plant immobilizes contaminants in the soil or sediment, reducing their mobility and bioavailability. Plant roots bind the contaminants such as heavy metals in the soil matrix, preventing the leaching and uptake by other organisms. And next one is the volatilization. In phytovolatilization, plants absorb contaminants from the soil or water and release them into the atmosphere in volatile forms through transpiration and metabolic processes. Here, volatile contaminants such as volatile organic compounds or mercury are taken up by the plants and released into the atmosphere. That can be captured or dispersed. And next one is the monitoring and management. This requires continuous monitoring and management throughout the phytoremediation process. Monitoring is conducted to assess treatment effectiveness, plant health, contaminant concentration and environment impacts. Management practices such as irrigation, fertilization, pest control and maintenance are implemented to optimize plant growth and remediation performance. So now what are the advantages? It is a sustainable method, it is cost effective method and also versatile method. So it also gives ecosystem benefits, but still there are certain limitations like time consuming. It is site specific factors influence it, and there should be regulatory approval should be brought, and also it may lead to secondary impacts, so that has to be taken in account. So overall we can say that phytoremediation is a promising and versatile remediation technique that offers potential benefits for its environmental protection, public health and ecosystem restoration. It is often employed as a part of integrated remediation strategies that combine phytoremediation with other treatment methods to achieve comprehensive cleanup for contaminated sites. And next one is soil heating. It is nothing but we are going to heat the soil by using it's a thermal remediation method for treating organic contaminants such as petroleum hydrocarbons, volatile organic compounds, polychlorinated biphenyls and certain pesticides. So here we have two methods: in situ, at this place itself, at the same place itself, we can go for heating, or you can carry the transport the soil into other places, and you can go for exitive heating also. So this method, in this method, what is the advantages? Rapid treatment of contaminated soils is possible, and effective removal of destruction of volatile and semi-volatile organic contaminants is present. Versatility for treating of wide range of contaminants is possible, and minimization of soil volume requires disposal and associated costs, as treated soils can be often reused and returned to the site. So, and what are the limitations? We have some limitations: high energy requirement, as we have seen in incineration, potential for air emission, site specific factors influence it, and we have to go for regulatory approval, and also the workers' health and safety also should be taken into account. I hope you all have understood about the remediation by soil heating as well as the phyto remediation, and thank you for watching.